You have to restart. So the first problem uses the unit circle. So first of all, we need a unit circle. Who's good at
Who knows the unit circle? Go for it.
No, she was already getting ready.
No, no, don't copy it off the piece of paper. That's not going to serve a purpose. We can give the students a piece of paper.
I mean, I drew
They-
it first
Yeah,
and then I
yeah,
used to put
because-
on
What we were talking about this morning, there are instructors that insist that students memorize that entire circle. That was one of the ones that was there. And they were tested on it. So that you need to be familiar with this. No. I want the whole
the
circle.
whole circle? Okay.
That's a good circle.
Yeah.
I was trying
Perhaps
to.
take the other marker, it's a bit darker.
One down.
Is that better or is it as bad?
It says
Maybe the
that.
other red.
I have good one.
It's not this blue and red then.
I have a good one.
No, she has one. Yes, yes, yes.
I do have one.
I think it is good.
Okay, so put your stuff on. That is really a very time-consuming thing. If students have to put that whole circle down at the beginning of a test, it's 5 minutes gone, right? Well, because they don't just sketch it, they really want it precise, I've noticed. I would call that biography.
We don't have to be accurate.
Okay. 5. And the other one. Takes a long time, doesn't it?
Do quadrant 1 and 2, we'll be happy
You just
with that.
quadrant 1 and 2 at the moment.
Yeah, because it really does take too long. And it's really easy to make a mistake.
She puts the angles on there, which isn't a bad idea to put the angles on there. Actually, the circle itself, I don't think puts the angles on, but
Yes, there are angles on the inside.
okay. Yeah, moet de Gries. 5 by 6. 5 by 6, yeah.
Yeah.
Okay, so and then, what else do we need?
Sines, cosines?
Yeah.
Oh, no, not like that.
No,
not like that. What you have to do is put the numbers here. They're on the
Okay.
circle. So,
When we talk about the unit circle, the one that the students memorize, they have the coordinates where you have the terminal side of the angle pi over 6. Coordinates at that point.
Sine.
No. Coordinates are cosine
Oh, like
of
that?
the angle
Oh,
and
I got it, I
sine.
got it.
So,
So here it would be like this.
yeah, and 1/2, yeah, and then the
I
next
don't
one.
look at that.
Yeah, okay.
Uh,
Just do the first side. You know, you guys can then do the rest, right? I cannot write this. I just do the spokes. I cannot do the circle. Okay, that's fine. Just for the. So now secant pi over 3. How would you do that? So we assume the whole circle is there, right?
They just spent 20 minutes of their test time creating that circle. Clearly, I don't like it.
So where is here? Why is it a half and not square root of 3 over 2?
because this is the cosine, this is the sine.
Okay. A lot of students do it wrong because sine comes before cosine, so therefore sine should come first. You know, when you say the trig functions, you say sine cosine, right?
Yeah, no. Okay.
Make it simple.
Computer.
Yeah, that's my thing. This is my angle. Cosine theta, sine theta. Computer science. and everything with the trig functions is C and S. Why? Sine, it's reciprocal as cosecant. Cosine is reciprocal as, so it's C and S. If you can get that into their heads, it's an easy
Except for
way.
tangent.
But tangent, it does.
Okay.
I say one has cos, one doesn't have cos.
Okay.
So, but then it works for tangent too, because tangent doesn't have an S.
Okay.
Okay, so negative 3 pi, that's not on the circle, right?
I would just follow the circle. Negative 1 pi, negative 2 pi, negative 3 pi. Sine of that is 0.
Okay.
I like that. I don't know if that's how people who use that circle do it. Do you know? Huh?
That's what I was doing. I mean.
Yeah, but I don't use that circle. Because, well, you'll see next time. What I do, because I don't like this is too much to remember.
Yeah,
My
but
brain
don't do
is.
the table yet, let's wait.
No, I'm not, but what I do for what, these are the points, and depends on the students. Initially, when I'm teaching it, I will do this. This is 0, this is pi over 2, this is exactly what you do, but I only do it with this. I only use the unit circle for angles whose terminal sides are on one of the axes. So if it's 7 pi over 2, I'm real good. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. There's a cosine and sine of 7 pi over 2. And I count with them, because they, which is what she did by going halfway with pi, and I would do it with, I don't know how else they do it with that big circle.
The problem is with the big circle is that there's so much on there that you might not see, you know, you lose it. With that little circle, it's, well, that happens to me. So 3 pi over 4.
Here, I know that the sine and the cosine, the absolute value is the same. And I know that the sine is going to be negative because...
But they will have this there.
They'll have it.
They will have this there, so you,
This,
but it's cotangent, but how do you do the cotangent?
So the cosine here is negative, so it's going to be minus
You go,
that
yeah.
divided by that.
You go a bit too
So it's
fast.
just going to be negative 1, that's it.
You went a little bit too fast there. What did she miss? I mean, she said it, but you didn't, you did it, but you didn't really.
That's cosine over sine?
Yeah,
Okay.
write that down. No, because it's, or at least ask the student. And, you know, because for them, you never know. For us, yes.
But no, that's important, because I have Calc 1s that don't know that cotangent is cosine over sine, in any case. So that's important, because everything's basically in terms of sine and cosine. Yeah, what you wrote before, I have a problem with. I don't understand this. I can figure it out, but that's not how we usually write things, okay?
But it's actually correct, it's division.
I know it's correct, but it's not American correct.
Yes, yes.
You mean she didn't put a line in between?
She wrote this.
What's wrong with that?
To me, I use that for ratios, but
Okay.
for students, the ratio going this,
Oh, it's this.
they're not gonna, oh, it's that?
No, that's American made for division.
Oh, this is the same as that with the two?
Yes, it's
division.
Oh,
It's
live and
division.
learn.
It's division.
That should be a
We
line
also
in
use
between.
a comment. So
Yeah.
I only do
All
that
right.
because I
You-
hate when the fractions
okay.
are so long and big and people get confused with big fractions.
Okay, so.
Yeah, but coming out of pre-calc, one of the things they need to do is be able to work with complex fractions, because you hit them a lot in calc. And the first thing that you should do is uncomplex it. I know that's not an English word, my classes have both adopted it, it's part of their vocabulary. And this is a simple form where you have to uncomplex it, because they get nastier ones in the calc. So it's not bad for them to see complex fractions along the way and get used to handling them.
Okay, anybody
Also in trig identity.
volunteer the table and how to make the table quickly?
Oh, I gotta volunteer.
Ah, yeah, because you heard it, huh?
Whichever one you want, there are two. Remember we did the two? Let's see what you remember, because she was there this morning.
Yeah, but she heard it this morning because,
Because somebody brought it from last night's tutor training to a student who was using the cheat sheet on the trig, and that cheat sheet has that full circle. And yeah, it's okay. I'm not a fan of it. I don't think it helps with certain things. But there's also, they need to know it, because when they move into Calc 1, they may be in a class where they're not allowed to use a calculator, and they're going to have to be able to figure these things out. The other thing, and it'll come up here, is when solving trig equations, the concept of a reference angle is super important, so that you don't quite get it there. Yeah, you don't quite get it there, but the idea of a reference angle needs to be gotten. And I think students need to be aware that the way in which their instructor is going to do it is going to vary from individual to individual. Oh, good. She's got it.
so now
She's counting.
you're setting up the table, so how do you explain to a student an easy way to remember?
Okay, so this is sine, cosine, tangent, you go in that order. Then you start with the angles, the denominator with the biggest number first, so that would be 6. Then you go to 4 and 3, all under pi. Then you start with counting. So sine 1, next one is 2, next one is 3. Then I'm trying to remember the way you did it. But so you add a radical to each one. So the radical of 1 is just 1. And you have radical 2, radical 3, and then everything's all over 2.
Why 2?
I know, that's because you assume they know the sine and cosine at that time. It's just a way to remember it.
Yeah.
They don't have, what I'm saying is you have explained how do you get to that
Yeah.
number. This is not a,
This is not a
fresh. They already have
In
that,
other words,
just
yeah,
showing a different way
you
to
go
remember.
with the right triangles, with 245-degree angles, that's how you get. And you show this is an easy way to keep track of it.
and then the cosine,
So cosine is, you count backwards, so it's the opposite. So it's 3, 2, 1, radicals on everything, 1 is just 1, all over 2 again. And then tangent you can calculate by doing sine over cosine, which will give you tangent. So in that case, you would draw the way she wrote it out, which would be the 1 over 2 times the cancel, so then the actual answer.
reduces,
Yeah.
And
they
then
don't cancel.
do the
We don't.
same thing.
We gotta fix one thing. Put your 1 in. The next one is an easy one, it's a 1.
It's a 1, just put a 1.
Okay?
Put
And
the one, put the one.
just anything over itself.
Okay.
You don't have to write that out because they
This-
should see that the same time you get to it.
You shouldn't have to write out. I don't know how he was doing it, the fellow that we were working with. But if you put this over this, it's complex. They both have a 2, multiply top and bottom by 2, 1 over radical 3, mission accomplished. And if you have those 3, you have everything.
And by writing it that way rather than the other way, you actually have the division sign right here. So you see
Yeah.
this over this.
Okay.
If you write your
It's,
column the other way,
3 over
where you
radical
put the
three,
angles
1
and
over
you don't see that.
Yeah, it's 1 over radical 3, which is radical 3 over
Oh,
3.
okay.
To be honest with you, now, here you gotta deal with the instructor, whatever their will is.
Yeah.
When, in my class, if I had to find the secant of pi over 6, and they told me it was 2 over radical 3, I'm more than happy. They don't have to rationalize the denominator. Right here, I'm just as happy with this. I really don't care. I know that in intermediate, they're told no radicals in the denominator. In pre-calc, I don't care, to be honest with you.
Yeah, is there, what's the utility there normally? Is that,
Yeah.
It's like, okay,
Radical, right?
yeah, This is fine for me. I think the answers in the back of the book are written without a radical in the denominator. But think about it this way. When you're in basic math, what do? You're told you have to write this most of the time. In algebra, when's the last time you wrote this? Or this? Right? You write improper fractions. The notation sort of dictates things. So that what we do in one course, you go to the next course, you don't necessarily do the same thing. So that here, I'm happy. Calculus, I love radicals in the denominator.
It's easier to work with.
Oh.
Take the derivative usually, you don't want to rationalize before you take a derivative, right?
Versus,
It's the same.
when you start to talk about where is this undefined, and when is this zero, it's a lot easier to do here than it is to do over here. So the radical in the denominator is much better in calculus. Don't explain that to a kid in intermediate. Because they're supposed to rationalize, multiply by conjugate, whatever it is. So it's really, you know, a matter of where they're at.
Now, this table, this is the basic table which I personally set up when I work with triangles, and I start with triangles, I don't have a book for that.
Yeah.
Now, you can expand this to further. If you don't, Dr. Feigenbaum always has a circle for
I like
the
my
unit
circle.
one. But this is actually, if I expand this and I'll squeeze the 0 here and the pi over 2, this still works because 0 over 2 is 0 and the square root of 4
2 over 2.
over 2
Yeah.
is 1. So the whole thing works and this backwards and then you can do the rest. I then, because I don't use the circle, I can't draw circles for the life of me. I also put then pi and 3 pi over 2 here. So in other words, I kind of put this on my table. I don't put this on there because then it's reference angles and you have to figure out what the sign is. But sign SIGN. But again, see what the student comes with, okay?
Yeah.
Now some, as we discussed before, some students will come with the whole table.
From 0 to 360.
That's you know, that's,
And not only that, it's 2 shades, am I correct? I think the shades are such that if it's shaded, it's where the inverse trig functions are defined, or if it's not shaded, one of the
you
two.
better remember correctly. The student. So, yeah?
I have a question. If a student can, my understanding is professor never even went over the unit circle, so they have no concept that sine and cosine are coordinates. They have no understanding. Should I take the time to explain it? Or
No, because
they're just memorizing the table and they have no understanding of the circle.
that's a very hard one to say. If I would say, be happy if they understand what they gain for you, with you. No, in the one, and the back walking, just
But I don't think they're doing the trivia though.
They are doing the table.
Some are.
Yeah.
And I know what
Yeah.
can go with what the student wants. Some of these students are very happy. You tell me the answer. I don't care how, where, why, or when. Others need to understand. And if the student needs to understand, then go with it. Because, I mean, I'm seeing things now with the calc. I have certain expectations when they do a max-min problem. Not everybody does the domain and makes them justify that it's a max or a min. So that you're gonna find different things. I disagree completely with that philosophy. Zip it. Oops.
okay. So, yeah, obviously, what was the question? I don't think you have to go. How no? Yeah, pi over 20 pi over 4 is fine, right? So anybody willing to explain how you use this to do cosine 5 pi over 6? Because that's not on my table, whichever version look at, unless you have the whole table. Is anybody willing to do that, explain to students how you get? Okay, Akuna, reference?
They'll take it away, explain. I pass it to
Do you know reference angle?
5/6.
Yeah, okay.
But how do you know it? Go up,
Okay.
yeah. Because there's different ways, and again, what you do and the way you handle it is gonna be student
I
dependent.
would go either to this or to
No,
this.
no circle,
Oh.
no circle, no circle.
That's how I would do it, and I would say 5/6,
No, no, no,
the
no.
same reflected.
Okay, that
You don't-
So a sign is.
I mean, for me,
I'm sorry.
No, no, no. You're
With the
right,
label, I have to-
you're right, but,
because I.
and then this is the but. If they're not working off the circle, draw your angle 5 pi over 6.
What do you mean?
You can do it with the circle if you
No,
want.
without the circle.
No, I just draw it without the circle. Draw your angle 5 pi over 6.
Yeah, okay.
All right.
Um,
Arrow, where's the angle?
right.
Okay. That's the angle 5 pi over 6. By definition, the reference angle is pi over 6 the rest of the way, the shortest distance from the terminal side to the x-axis. So, there we go. The way in which things are done, someplace, somewhere, the instructor should have done what you were about to do. Say that the points here are pi over 6, reference angle, and points here pi over 6 here. The coordinates are the same except for signs,
Yes.
plus and minus. So that when a student is computing, what is it, cosine?
Cosine.
Yes.
They're really computing the cosine of the reference angle
So
and attaching the appropriate SIGN.
Like I always,
So
I
cosine
know,
is the
I know you
next
always
argument.
tell
Yeah,
us
so it would be
to
what?
but I always like.
So it is negative what? Negative,
Because I
yes,
see
take the
better.
mark in that word.
And then.
So we would go.
Do it
to
in your mind,
the
and I'll tell you
negative
why.
Okay, so,
3
over
square root of 3.
okay, so,
And cosine is,
yes, it's a negative, she
Oh, I
put the
was
sign next to the.
Oh, okay. do you know how they keep the quadrant, signs of the sine and cosine straight?
Also then take out.
Yeah,
I didn't say that, I did something else, I won't say.
I think
anything
most
else.
of us say
Unless
that.
you
All
change
students think
things.
that. Yeah, oddly enough, that acronym they remember. And it's just the three, all three. What are you looking at? All three are positive, sine is positive, tangent, cosine, you're just working
That's
with the
good.
three.
The other one is.
It's an acronym, and that one they do keep with them.
I haven't heard that.
It's like foil, they keep with them. They don't always know what it means, but they keep it with
Okay,
them.
yeah, they have to.
All right, one of the reasons, why you want radians, okay?
I feel like I see better in degrees than in radians. I always try to convert first to see where it is, and
Okay.
then I'm in the circle, then I find out what.
Where's
it is.
14 pi over 3 radians? You think I'm converting that to degrees?
I do that. but
No,
I-
That's a
I don't
lot
know.
of arithmetic. Here, change this to a mixed number.
Okay, so let me see.
It's 4 and 2/3,
Okay.
1 pi, 2 pi, 3 pi, 4 pi. Now I have to go 2/3 of a pi, puts me here.
I have another method for that. I mean, I don't know, I just figured this out.
Something else.
Good.
We're
Maybe
looking for more.
it might work, it might not, but 14, so pick a number that is like a multiple of 3 near to 14. So that would be, I would say 15.
Okay.
So that is 3 multiplied by 5. So I would say that, okay, 5 pi minus pi over 3. Because 14 is 15 minus 1.
You are assuming that the student knows it.
Remember it.
Knows arithmetic.
But they tend to like.
It
all
worked, I
the
mean,
things,
No.
you're absolutely right, and it's a good method.
I mean, if you're in calc or some higher thing,
It uses reference angle.
this might work for you. Yeah.
It uses reference.
Yeah.
angle.
Yeah.
No,
things in one.
you've got to figure out what works for the student. The problem is their fractions. They're going to go revolt because there's fractions. But the fractions aren't so bad.
Okay, 14.
'Cause I'll show you
15
something later
minus
on.
1, pick one thing here. 5. over 3.
Yeah.
So just distribute 15 pi.
You know, it's very good, it's
Yeah.
basically,
And I think it works for most, all of them.
Let me ask you this, how you would do it with a student. Let's suppose you want to find out where the cosine is -1/2. Now, I always tell them that's quadrant 3 or quadrant 2. There's my angle. But I drop the sign, the 1/2, cosine's a half at pi over 3, so my reference angle is pi over 3. Reference pi over 3. Now, how do you find the angle?
I would say that, okay, this angle is, this is pi. So this angle is like more than pi. So I would say that pi plus pi over 3. While on this side, it is pi.
And go back.
But it's like, yeah, we're going back. So we'll just do pi minus
Yeah.
pi over 3.
So can I have something with this though? Why are you using 15 and not 12? What if I want to use 12?
Okay,
Would
so
that work?
12 would be
Why always have to go
12
up?
Yeah,
plus 2
yeah.
pi
because 2 pi
over 3. So it would be
yeah.
4 pi plus 2 pi over 3. Then you need to convert this 2 pi over 3 into 3 minus 1.
You don't have to, because most students will know where 2 pi y is.
Okay.
I have the impression that most students know the first quadrant without 12.
First quadrant.
The
The
first
2
and
pi
second,
is
first and 2 pi over.
No, some of them get confused that a whole pi is here. A whole pi should be complete revolution.
Yeah, because of
That's the key. Because here, if they know this is a whole pi, and this is a third of a pi, and the word pi in my mind is now pizza pie. If this is a third, then this must be 2/3. I try to use some common sense. And over here, if this is a whole pi and this is a third, I have 1 1/3 pies, which becomes 4 pi over 3. I try to use the word pi, you keep saying pi, but I keep thinking of it as P-I-E.
Yeah.
And that, so that maybe they'll get some sense with the fractions there, because they do understand more or less that, you know, when they slice up the piece of pie into 8 parts, that they're each getting an eighth, I would hope, by the time they hit pre-calc. I'm not always sure. But something to help them to get things straight with this.
But because the pi is
Yeah,
2 pi.
yeah, that's, so.
Yeah, but it's two,
It's
but
2 pi.
that you do with labeling. It's, I'll let you know, because my class is an interesting one this semester, my
Yeah.
pre-calc.
This,
It works.
the fraction method also helps when they just ask to graph, I'm just,
Yeah.
11 pi over 7. That's not one of the basic ones, right? So where is it? And converting that, it's like ridiculous. But again, it's 1 and 4, like I'm saying it,
So that means you
1
make-
and 4, and 4 sevenths is a
I
little bit more than a half, so you can, you know, if you do,
think I like them.
so if you do 11 pi
Try
over
to
7,
work off their common sense.
so you.
Sometimes you begin to wonder, where is it? And I try to use that, whatever is common sense for them. It may not be your common sense.
Also, make sure you put arrows when you do angles,
Okay,
because
go
the
both ways.
terminal side alone does, you know, how many angles does that give you? Quite a bit. So you put the arrow so that, you know, that the student know, also then they get into the habit. Learn them, good habits. Now, yeah, what was the last
Oh,
one?
if we're talking about good habits, insist that they're neat and organized on paper. Or their instructor will not read their work on a test.
I looked down, I was like,
So, the
This
next,
is getting near what I don't want to say.
so now the triangle. Triangle, anybody knows the triangle method? Bhavya, anybody else? Okay, Bhavya just already.
Yeah. I don't think anybody on our board place is going to use
One
it.
thing is that good habits, never write this. It's X, theta, I don't care what letter, but otherwise it's sine.
a lot of calc students, when they're doing the chain rule, they mistake that.
Yeah. So
Oh,
it's the sine of x, right? It's not sine x, it's the sine of x. That's also most of, yeah, Dr. Freigenbaum is doing the plotter tour.
you laugh.
I'm like,
We've
how?
seen
Well,
it
how?
more than we'd like.
I have seen
It's
students
the
who
problem,
come and do
but-
that.
That's because, it's a couple reasons. They don't understand that these two are attached together, that sine is a function. And part of the problem